This is the second free response question for Unit 1. So we have another problem that we have a graphical representation and a tabular representation, and we're asked to do some different things with limits. So here we go. So for the first part, we're going to use the graph in the table and estimate the limit as x approaches 0 of f of x minus g of x. Now I would just to remind you that if you have the limit of two functions subtracted, that's going to be the same as if you broke them apart and you did the limit of each function and then subtracted that. So that's how we're going to get the answer to this problem. So I would start off and just find the limit as x approaches 0 of f of x. And then specifically writing that down could get you a point on this problem. So as we go to the graph, because the f of x is the graph, and if we approach 0 from the left and from the right, on both sides, the graph approaches 2. So that is going to be 2. Right, and then I would find the limit as x approaches 0 of g of x. So we would go to the table. Now, 0 is not in the table, but that's okay. We know 0 would fall right here in between those two values. So from the left and from the right, as these values get closer and closer to 0, you can tell that the values of y in your table are getting closer and closer to 2. All right, so that right there, writing both of those according to what I was the rubric I was looking at, will give you 1 point. The other point is going to come from you telling the people grading your test that you know the properties of limits. Now, I don't know if it's necessary that you write this out, but I would go ahead and do it just in case. All right, so that's that property I was talking about at the beginning. And then just go ahead and fill in your two limits. So this value is 0. So all of that gets you another point. All right, let's look at another one. All right, so for each of the values 1, 2, 4, and 6, we're going to determine the limit, and if it doesn't exist, we're going to tell why, and we are going to make sure we use correct limit notation. Okay, so let's talk about 1. So the limit as x approaches 1, and we're using f of x on this one. So we'll go to the graph. And we're going to look at 1. So 1 is right here. So we're going to approach 1 from the left, and that limit from the left is 1. And then we're going to approach 1 from the right, and that limit is 0. So this is not going to exist. So I'm going to erase my equals and say that limit does not exist, but we do need to tell why. And the reason why is because the limit as x approaches 1 from the left of f of x is 1, and the limit as x approaches 1 from the right of f of x is 0. And then I would take another second to say that those are not equal. All right, and that definitely covers the reasons. Okay, so let's go to another color. All right, let's to a equals 2. So we want to find the limit as x approaches 2 of f of x. All right. Sorry, I got distracted by my phone ringing. So we're going to check on 2. So we're going to approach 2 from the left. We're going to approach 2 from the right. And that is going to be 1. And that's all we have to do. That's using the appropriate notation. It does exist. We don't have to explain why. So we're good on that one. All right. And then let's go to 4. All right, so we're going to approach 4 from the left, approach 4 from the right. That's going to give us this point right here, which is -1. And again, that's all we have to show for that one. All right, and the last one we're going to do is 6. So make sure for each of those you're writing the limit and then you're also writing the function you're using. You cannot leave that off. Okay. We got some kind of weird thing going on 6. So we're approaching from the left and we're approaching from the right, and they were both approaching infinity, but the limit does not exist because there's definitely a vertical asymptote there. So that is going to be discontinuous, and the limit doesn't exist. So we kind of have to explain why. So the reason is because the limit as x approaches 6 from the left, of f of x is equal to infinity, and the limit as x approaches 6 from the right is equal to infinity. So infinity means the limit does not exist. And it definitely doesn't exist if we have that vertical asymptote there. All right. Oh, I didn't tell you your points. So this will get you 1 point. These 2 together will get you 1 point. And this last one will give you 1 point. All right, so let's look at C. We want to know if f is continuous at -3. All right, so we got a -3, and we do have some things going on. But remember, for continuous, we need to show that the limit as x approaches -3 of f of x equals f of -3. So when we do the limit, we approach from the left and from the right, and they approach the same thing, which is -1. So we would want to write that down. All right, and then we would need to find f of -3. So f of -3 is this point right here. It's where there's a hole right here. So we don't look at the hole to find the value of the function. We look at the darkened point to find the value of the function. So that is going to be 2. So we would say no. F is not continuous approaches negative 3 of f of x does not equal f of negative 3. All right, and let's see. Looks like this gives you 1 point, this gives you 1 point, and all this gives you 1 point. Now, but saying it takes that point away. I'm not being specific about where we're talking about, where the function is continuous, takes a point away. So be really careful with your notation. Okay, and then the very last one. We haven't really done this in a long time, talking about a difference quotient, but a difference quotient is just subtraction and division put together, which is basically the slope formula. So this one is the only one I think that, no, the first one asks us to use G, but this one we're talking about G, and we want to find the difference quotient that best approximates the instantaneous rate of change. There are several different ones you could use. 0 is right here, so 0 has to fall in between the points that you use. When I did it, I just went ahead and used the points on each side of 0 like directly. That is not the only way to do this problem. You could really use any values in this table as long as 0 falls in between those points. So the one I decided was that one, and so I just went ahead and I said that G of the point on the right minus G of the point right on the left, directly on the left, over those two subtracted from each other. So it's basically the slope formula. You could take this a step farther if you didn't want to write it that way, and you could use the actual y points. That's fine. That's perfect as well. You could stop right here, or you could do this, or you could do both. I wouldn't, especially on a non-calculator one, I wouldn't try to subtract these. I would just leave it like that, because if you subtract these and get them wrong, you miss your 1 point